In this lesson, we will discuss pattern evaluation. We will start with discussing the limitation of support confidence framework. Then we will discuss two interestingness measures, the lift and chi-square. Pattern mining algorithms results in large number of frequent patterns. However, not all of these frequent patterns are interesting. That's why we need interestingness measures. These measures fall into two categories, objective and subjective. Objective measures are those that can be computed using an algorithm or formula. In other words, they have quantifiable values, and if these values are large or small, we can interpret the interestingness accordingly. Examples of these objective measures are support, confidence, correlation, lift chi-square, among others. On the other hand, subjective measures are application-based. They don't have a specific formula. Instead, we need to collect different types of information. For example, if I'm interested in learning about the purchasing behaviors in a store from Thursday through Sunday, I might need to answer specific queries, identify unexpected patterns, analyze time-based patterns, and consult against an existing knowledge base to come up with this subjective measure. So far, we learned two objective measures, the support and confidence, but these measures have limitation. Let's walk through this example. This is a two-way contingency table. It shows number of students who either play basketball or do not play basketball, whether the students eat cereal or do not eat cereal. The total number of students is 1,000, and as you can see, we have 750 who eat cereal and 250 who do not eat cereal. Next, we go and compute support and confidence for the rule that states playing basketball may also lead to eating cereal. The support is 40%, confidence 66.7. So at the first glance, this looks reasonable. However, if we start to look at the data distribution, we see that 75% of the students eat cereal, which is greater than the confidence of the rule, which means this strong association rule is somewhat misleading. Here's a contradictory rule to the previous one, which states that not playing basketball may lead to eating cereal. The support is a little bit lower. Previously it was 40%, now is 35%, but the confidence is much higher. So we went from 66.7 to 87.5. So the point that we are trying to make here is support and confidence alone can sometimes be misleading because we don't consider the overall distribution of the data. To address the limitations of support confidence framework, lift is a measure of how much more likely or less likely two item sets or events like B and C occur together than occurring independently. So unlike just looking at support, which tells us how often an event occurs, lift provides correlation-based perspective. In other words, our two events are actually related or coincidental. In this example, we compute the lift for two rules, playing basketball and eating cereal, then the contradictory one, playing basketball and not eating cereal. As you can see, the lift value for the first rule suggests negative correlation between B and C, whereas the lift to B not C is positively correlated, which suggests that eating cereal is less common among basketball players than we might assume based on looking at support and confidence alone. Another measure is chi-square that we studied in hypothesis testing. The process starts with a null hypothesis, which assumes that two variables in the mining rule are independent. Then we compute the chi-square statistic and decide whether we can reject the null hypothesis. If we successfully reject the null hypothesis, we conclude that the variables are not independent or correlated. In other words, there is a statistical significance to provide evidence that the relationship did not occur by random chance. So everything up to this point follows standard statistics. However, once we reject the null hypothesis and establish a correlation, people often take it a step further, sometimes making claims about the direction of the correlation, positive or negative, without sufficient backing. So what we're trying to say here, chi-square simply tells us that the variables are not independent or correlated, but it doesn't specify the nature of their relationship. Now that we understand left and chi-square, we can discuss their limitations. Left and chi-square are useful as long as we don't have a large number of null transactions. Consider this modified example. Not B, not C used to be 50, less than B and C. Now we distorted this example and made not B, not C 1 million. So now B and C become rare, which is going to distort the computation of the left and chi-square. Here's a slightly modified example. Suppose we set up B and C as 100, not B, not C as 1 million. You can see how the left value shows strong positive correlation between the variables, but in fact, this is an overestimation of the correlation because B and C occurring together is very rare in comparison to not B, not C. In summary, we discussed the limitations of support confidence framework and learned about two new measures, left and chi-square, and also discussed their limitations.